Hello everybody, I hope everybody is doing fine and studying hard. We'll talk today about behavioral sciences. We'll start by talking about observational studies. As you can see here, in the timeline, we have case control, which are retrospective or cross-sectional studies, which take a snapshot in time, and cohort studies, which are prospective mainly. There are retrospective cohort, but mainly prospective here. So let's start with case control. So case control, as we said, it's a retrospective study. The easy thing that the name gives it, so we have cases, people with diseases, and we have some control, people without a disease. So we start with the disease, go to look for risk factors of that disease. We use something called exposure odds ratio to measure it. It tells the odds of being exposed to a risk factor between the cases and the controls. How much are the odds? So usually it's more in the cases. So it tells you that the odds are more by 2, by 1.1, by 3. How much are the odds to develop a disease between the cases and the controls? Okay. When doing the case and control, we have some independent variables as age and sex. So we have to match these between the cases and control to prevent any bias. It's cheaper than cohort because we already have cases, so there is no incidence. The cases are already here. Okay. Example would be like looking for people with cirrhosis and without cirrhosis. So these are the cases, and looking for the risk factors that leads to either. Maybe it would be alcohol use as a risk factor, something like that. But we start with people with disease, people without disease, and then we go back and look for the risk factors. Cohort study. In cohort study, we start with the risk factors. It's a prospective study, as we said. So we start with the risk factors, divide the groups into exposed, either exposed to the risk factors or non-exposed to the risk factors, and then we follow them on time to see who develops the disease. There are retrospective cohort. I don't think it's very important for the exam, but the prospective cohort is the important because we follow people over time until the disease occurs. We can provide the incidence in this study. We can calculate the incidence. We use relative risk and attributable risk, RR and AR. So as we said, we follow until the disease occurs. An example would be like we'd follow smokers and non-smokers over time to see who develops lung cancer. One of the problems is loss of follow-up. We'll talk more about the biases in another video. It's important to remember these definitions. Sometimes they seem easy, and they are easy, but sometimes they try to trick you in the questions. So set it straight and remember it. The third type of these observational studies that we don't have any interventions in here, we just observe, is the cross-sectional study. As we said previously, it's like we take something and we do a cross-section. We do a cross-section here in time. We go into a specific period of time and see both the exposure and the outcome at one specific point of time. It's known as a prevalence study. It provides the prevalence of the disease. There's something called the prevalence odds ratio. So we talked that there's exposure odds ratio in case control, but there's something called prevalence odds ratio, which compares the prevalence of diseases in different populations. Since we said the exposure and the outcome are present for some time before the study, we cannot determine the cause between the exposure and the outcome, but we can determine only the association. We know that there is association, but not the cause. It's very cheap study, it's fast to do, but there's no incidence and we cannot determine the cause between the risk factor and disease. One example would be looking for a population for the prevalence of a certain disease, like the prevalence of breast cancer in a population. All what we would know that in certain age groups there is more breast cancer in this population, or something like that. Okay? There are other stuff that you might want to know, not that important, but there is also case series studies. Patients, these are patients who are already diagnosed. We follow them to know the natural history of usually uncommon diseases. There are clinical trials. These are intervention clinical trials, not observational anymore. We have exposed people who give them treatment, and we have the other group receive only placebo. We see what's the outcome. We have something called meta-analysis, combines data from multiple studies to provide more power. Let's do some examples. Let's look at the incidence. What's the incidence? The incidence is the frequency of new cases of a disease in a population of risk over a specific time. So the incidence rate is the number of new cases at the population at risk in a period of time. It looks at new cases. Something happens. Incidence new. While prevalence measures those who have the disease, who already have the disease, not the new cases, the already present cases in a population over time. What increases the prevalence? If there is prolonged survival duration or like good quality of care, the prevalence increases. The prevalence number of existing cases divided by the population at risk over time. We'll talk now about relative risk. We said previously that relative risk and attributable risk are used in cohort studies. So what's relative risk? It's the ratio of risk in the exposed group divided by the ratio divided to the unexposed group, to the risk in unexposed group. So the risk in exposed divided by the risk unexposed. This is the formula that you have to know: incidence in exposed divided by incidence in non-exposed. We're asking how much more likely is there a risk. So the relative risk of 1, which is a null value, tells us there is no association between the risk factor and the disease. But if it's more than 1, there's a positive association, which means as we increase the risk factors, there is more disease. While relative risk is less than 1, there's negative association between the risk factor and the disease. The further from the value of from 1, the stronger the association. We'll talk now about attributable risk and absolute risk reduction. There is a slight difference between attributable risk and absolute risk reduction, but I don't think that it's very important to know it, and I usually put them together. So we are asking how many more cases in one group. So it's the incidence in exposed or the event. The correct thing I think is the event rate in exposed, but I memorized it like the incidence in exposed. I don't think there's a big difference, but it should be the event rate in the exposed minus the incidence or event rate in non-exposed. The numbers needed to treat, or the number needed to harm, are the number of people that should receive treatment to prevent one event. It's the reverse of absolute risk reduction or attributable risk. And it's the same here. It's just a different name. It applies to different, but it's the same principle. The numbers needed to harm. Number of people that must be treated for one adverse event. So harm, we're looking for an adverse event to occur. The numbers needed to harm are the reverse of 1 over the attributable risk or 1 over the absolute risk reduction. Relative risk reduction. The risk reduction due to treatment, RRR. The equation is 1 minus relative risk. Absolute risk percent. This looks the excess of risk in the exposed population that can be attributed to the risk factor. It's a percent. Risk in exposed minus risk in non-exposed over the risk in exposed. Or there is an easier formula, which is relative risk minus 1 over relative risk. If you can get the relative risk, it's easier to use this formula. What are the odds ratio? We said the odds ratio are for the case controls. What helps me to remember that case controls, CC or CCU, need to go to the OR, operation room, whatever helps you. Odds ratio, case control. So there is increased odds of getting the disease with exposure to the risk versus non-exposure to the risk. The odds of exposure for cases divided by the odds of exposure for controls. There are many formulas for odds ratio, but the one that I found most that works with many tables and without getting it wrong is this one, that you need to know that's the odds of exposure for cases. So if you see here that the case is lung cancer, this is the disease, no lung cancer, no disease, and this is the exposure, smokers or non-smokers. So it's the odds in cases divided by the odds of exposure for controls. So we divide the cases, the exposed and non-exposed in the cases, here A divided by C, then we divide them all by the non-cases or controls, B divided by D. There's another formula where we cross A times D, AD divided by B times C. But the thing is that sometimes they don't give you this table like this. Sometimes the diseases are in this area and the controls are in here. So if you remember that it's the odds of exposure for cases divided by control, you'll get it every time. So in this case, A divided by C divided by B divided by D, you'll have the answer. So we have another example here. Always, when you're giving a table or you're formulating a table, look where the disease is, and there's no disease, and where's the exposure and non-exposed. So if we want to get, if they give it the other way, try to make it this way, so it will be easier to calculate. So the incidence, if we are asked to get the incidence in exposed, we'll get it A divided by all the exposed, the disease divided by all the exposed. Well, the incidence in non-exposed is C divided by C plus D. This is the incidence in non-exposed. So, as we said, people, A is people with the disease divided by people at risk of getting the disease because they're exposed. People with the disease divided by people at risk of the disease. They ask for incidence in exposed. How about the incidence in non-exposed? People with the disease in non-exposed group divided by all people at risk in the non-exposed group. C divided by C plus D. Then it becomes easier if they ask about the relative risk, to divide the incidence in exposed by the incidence in non-exposed. This is the incidence in exposed divided by incidence in non-exposed. Oh, sorry. As we said, relative risk is the incidence in exposed divided by the incidence in non-exposed. We've already got the incidence in the exposed and non-exposed in the previous equation. Attributable risk or absolute risk reduction, the difference is the minus. We subtract the incidence in exposed from the incidence in non-exposed. The relative risk reduction, 1 minus RR, they didn't ask it in here. How about the odds ratio? So this time I changed the table. These are people with family history of cancer. So these are the exposed and no family history of cancer, non-exposed. Usually the cancer people or the diseased people are in this part of the table, but this time they changed it, so you can't use it you can't use the previous equation without getting confused. But if you use the odds, the equation that I said before, which are the odds of exposure for the cases, and you know the cases are the cancer, so divide 60 by 20 divided by the odds of exposure for non-diseased or no cancer here. So 120 divided by 200, you'll get it, which is 5. This is the original one. Here it is changed. Another example. Is this 2 by 2 table where we have people with a disease or people with no disease or are well. Here we have people who are exposed, people non-exposed. So assuming it's a cohort study, what's the incidence rate of the exposed? As we said before, to get the incidence of a certain group, we get the diseased people, which is 520, divided by all the people who are at risk in this group, which are 520 plus 175, 695. Okay? Assuming it's a cohort study, what's the relative risk? So what was the equation? Relative risk. Incidence in exposed divided by incidence in non-exposed. So the incidence in exposed, we already got it, which is this. The incidence in non-exposed, which is the same. People with a disease in the non-exposed group divided by all people at risk. Assuming it's a case control. What's the odds ratio? So odds ratio with case control, CC with OR. As we said before, we go for the disease, the odds of exposure in the diseases, 520 divided by 80 divided by 175 over 225. AC divided by B over D. Assuming it's a cross-sectional study, I'm gonna get it all. What's the prevalence? The prevalence is the people with the disease divided by all people at risk, or all screened people. So the prevalence, we want to know the prevalence of the disease. All people with the disease are 600 divided by all people who are screened is 1000. So all diseased divided by all screened is the prevalence. Assuming it's a disease outbreak, what's the attack rate for the people who did not eat the food? So the attack rate, they're asking us about the incidence of new cases who developed the outbreak. So incidence, but they're asking for people who did not eat the food. So incidence in non-exposed group. As we said, the incidence in non-exposed, we go horizontally, the people with the disease divided by all people at risk. So 80 divided by 305. Assuming it's a cohort study, what's the attributable risk? So attributable risk is incidence in exposed minus the incidence in non-exposed. We got the incidence in exposed so many times in this example, minus the incidence in non-exposed. Let's see this example. A physician is looking for risk factor for pancreatitis. He interviewed 200 hospitalized patients with pancreatitis and 200 hospitalized patients without pancreatitis. What's the study type? So he has people with a disease and people without the disease, which are the control, case control, and he's looking for the risk factors. A group of smokers and a group of non-smokers are followed for over 20 years. Every 3 years, it's determined who develops cancer and who does not. What's the type of the study? So we have people at risk and people with no risk factors, and we follow them over time to see the development of disease. So it's a prospective study, it's a cohort study. Let's see this example. We talked about the number needed to harm or not, on the number needed to treat. So if you have a drug X, in drug X, when we give drug X, there are certain side effects, which are the deaths in this example. 60 people died and only 20 are living. We give the placebo, 38 people died and 38 lived. So they're asking for the numbers needed to harm. So the number of people that are treated with the drug for adverse event to occur or to die in here. So we go for the event rate. So the number needed to harm is 1 divided by attributable risk. So we'll have to get attributable risk. So we get the incidence, or as I said, the event rate in the treatment. The treatment groups are the exposed group. I like to use the incidence in exposed. I don't know if this is right, but it always works. You can say the event rate, but I always memorize it that it's the incidence rate. Incidence in exposed. Exposed here are people with drug X. So 60 people with the event, with the side effect or the death, divided by all people, gives us 0.75. So death is divided by all people who got the drug X. The event rate of the placebo or the non-exposed, that is due to the placebo divided by all people who got the placebo. 38 divided by 38 plus 38, which is 0.5. So the attributable risk is the incidence in exposed minus the incidence in non-exposed, which is 0.25. The numbers needed to harm is the reverse, 1 over 0.25, which are 4. So 4 people must be treated with drug X for the event occur, which is death, to occur in this example. So let's revise what we've said in this session. We said there are cases, there are certain types of observational studies, case control, which is retrospective. We have people with the disease and people without the disease. And there is the exposure odds ratio. We have the cohort study, which is a prospective study looking for incidence. We have people with it divides people who are exposed or people who are non-exposed, looking for the risk factors. We use relative risk and attributable risk. We have the third one, which is cross-sectional study, where it is a snapshot in time. It's a prevalence study, both the exposure and the outcome in a certain period of time. It looks only for the association between the risk factor and the disease, but not the cause, and no incidence. One thing to note is the prevalence odds ratio. We said that we have case series and clinical trials and meta-analysis. We talked about the incidence. And we said the incidence is the number of new cases or acute cases divided the population at risk at a certain time, while the prevalence, the number of people with the disease, all people with the disease at a certain time. We talked about how we calculate the relative risk, incidence in exposed divided by incidence in non-exposed. The null is 1, so there's no association between the risk factor and the disease. While if the relative risk is more than 1, there is a positive association between the risk factor and the disease. If it's less than 1, there is negative association. We said there is attributable risk and absolute risk reduction. In attributable risk and absolute risk reduction, we subtract, while in relative risk we divide it. It's the same thing, the incidence in exposed and incidence in non-exposed, we subtract them here. And then the reverse gives us numbers needed to treat or the number needed to harm. There's something else called relative risk reduction and absolute risk percent. In relative risk, the risk reduction due to treatment, 1 minus the relative risk, while the absolute risk percent, either using this formula, risk in exposed minus risk in unexposed divided by the risk in exposed, or by relative risk, which is easier, relative risk minus 1 divided by relative risk. The odds ratio, which are for case control, as we said, the increased odds the odds of getting the disease in exposed to risk versus the non-exposed to the risk.